Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this tutorial, we're going to look at the Apple Activity Rings animation, a beautiful animation. We did this as a Can It Be Done in React Native tutorial 3 years ago, and back then we didn't have access to all the primitives we have today to build such an example, so I really wanted to remake this tutorial with what we have access to today, namely Reanimated 3 and Skia. Back in 2020, we didn't have Angular gradients, we didn't have clipping masks, we didn't have shadows and so on. And we kind of went crazy to build the example. So we used a masked view to build the Angular gradient, which I think was a pretty clever idea, but then it meant that we had to do the progress circle using views and not SVG. And we had to play quite some trick to do it. But there were also, I think, not only a deficit in primitives back in 2020, also a deficit in knowledge. Because if I were to redo the same example with the primitives of 2020, I would do it very, very differently. And we're going to allude to a solution that we could have done back then at the end of the video. But how we do it in React Native? There is a simple case where we only go from 0 to 100. So here we draw the background circle, we draw a path as a circle that we animate from 0 to 1, and we draw a true circle for the tail and the head. The tail is below the progress path, and the head is above the progress path. And we can use a nice angular gradient, a sweep gradient, to colorize the path. Now, if we go from more than 100%, as soon as we hit an extra revolution, we need to rotate the sweep gradient to go along with the progression, and we need to add a shadow to the head and clip the head so the shadow doesn't go overboard the circle, and that is only visible in the direction it's pointing to. Here, using a clip path for the head might seem a bit overkill, and I'm going to show you two solutions. So one using a clip path, and a second one where we're going to build a simple shader to build the half circle with the shadow. And this is going to allude to the fact that you can build the whole example using a single shader. In fact, I mean, we only have circular things, so usually these things are very easy to deal with using shaders. In Apple's marketing materials, they use a shader to build these rings, which makes me believe that they might use also a shader in the real implementation. So that's something we're going to have a look at. And that's how I would have done it, I think, back in 2020. Since we had no primitives, this could have been a nicely done shader. So let's jump into VS Code. We are into VS Code here, and I have a boilerplate project which you can download from the video description in case you want to code along. So here I have the ring definition. So I actually took the colors from the Apple marketing materials. I have a random progress and a size for the ring, and the stroke width for the ring as well. And here, yeah, because I took these from the Apple shader, I just wanted to have a function to convert it as a color string. And so here, instead of drawing a circle for the background circle, I'm drawing the background color fully, and I'm going to clip with the inner and outer circle. And the reason I want to do this is that when I build the shadow of the head, I don't want the shadow to go over the background circle. So that's why we're going to use a clipping mask instead. So let's build the clipping mask. So we're going to draw. So we're going to create a clip. I can put it into a memo for good measure. And we're going to create an outer circle. And we're going to add a circle. So the center is okay, and the size, so size divided by 2 would be, yeah, I think that's correct. That would be the outer circle. Let's return it and draw it quickly to see. So let's try to to have a look. So I'm gonna do style, stroke, color, white, stroke, with, I don't know, 2. And here maybe I can just update this quickly. That looks good. Now let's do the inner one, and we're gonna merge the 2 and use it as a clipping path. There is another way to do it, and I'm just thinking about this now, is to draw the stroke path of the circle, and there is a stroke method in Skia that you can use that would give you the outline of a stroke path. Yeah, but I'm not gonna improvise this right now. Let's do like the 2 circles and merge it. So inner circle, and so the center is the same, and here we would remove the stroke width. I think that's correct. Can we draw it? I think that looks good. And so now what we want to do is to merge the 2 together. And so I'm gonna do Skia. So I'm gonna use a path up. So make from up. So we have outer circle, inner circle, and the operator, is it different? Yeah, that looks good. That looks good. So here, this one returns a valid path. So let's use that as a clipping now. So clip. Yeah, perfect. And I can remove this one. Very nice. So now let's draw the path, right? So I'm gonna create let's call it full path. We're gonna draw the full path, and then we're gonna have a path which is a trimmed version of this path based on animation. So I'm gonna put it into a memo as well. And so we have a path, and we need to count how many revolutions we have. So we have total progress. So if we have 2.7, it's 2 revolutions plus 70% of 2 pi. So if you have 2.5, it's 2 revolutions plus pi, plus 180 degrees. So how many revolutions do we have? So I'm actually gonna do a math floor to have like the number of full revolutions, and I can call it full revolutions. And I'm gonna do a math floor of total progress. So for each full revolution, we're gonna draw a full circle. So but here it should be, so this is correct. I'm just looking at this condition. So if we have 0, yeah, that's good. Copilot is good. So here we have a full circle, and we need to add the remaining. So we're gonna add an arc. So the add arc signature in React Native Skia is really cool because you pass the bounding rectangle and just the angles. And the angles are going to be 0. And so angle here is in degree. So it's going to be 360 times. So the fragment part, the decimal part of total progress, so that would be total progress modulo 1. So these angles should be correct. And the bounding box, I can actually have a little from circle function that gives me the bounding rectangle of, square of a circle, the square of a circle. So from circle, and these would be, the values, center and size divided by 2, is that? I don't think that's correct. It's not size divided by 2. It's size divided by 2 minus half of the stroke width. Because the size divided by 2 is, our size is the outer bound. So we need to remove half of the stroke because the stroke is at the center. And should I maybe move this into a variable? So let's stroke doesn't exist. Stroke width. Let's draw it. So path is full path. Stroke width is stroke width, and color, I can do, let's say, color 0. So we have some issue with the radius, I think. If it's not the clip mask, that is actually wrong. Let's see. Yeah, of course, here we only see, what? Okay, got it. I forgot to add style stroke. Okay, this is much better. Yeah, very good. And here, for good measure, we can rotate it by minus half of pi to have it exactly like on the Apple example. So we can do transform. Rotate is minus pi divided by 2. And of course, we need to use the center as the origin. Okay, so now let's animate the arc. I mean, one thing we can add quickly also is the tail, because the tail is easy and never moves, and the color also never changes. So the center would be full path, get point, the first point, get point at 0. Radius is stroke width divided by 2. Yeah, you see it in black. And the color would be the first color. Yeah, perfect. So you see the nice tail. So let's animate. So we're gonna need, I think I can just remove this one here. We're gonna create an animation value. So should we call it progress? No, I'm gonna call it trim, because the animation value is always gonna go from 0 to 1, but the progress goes above 1. So let's call it, or end, because, no, let's call it trim. Use shared value, default value is 0, and on mount, we're gonna start the animation. So use effect, oops, so we have, yeah, trim dot value, we go to 1, we don't go to total progress. Duration, I don't know, we can put 3 seconds. This looks good, and that gives us path, which we can calculate. I mean, one thing we can do is use full path and put the trim value here as an animation value. Let's have a look. I'm trying to shake here the phone. Okay, that looks good, and maybe also for good measure, so we can see it, I can add the head. But you see, this is where I need actually to calculate the path myself for now. So we're gonna create an animation and derived value called path, and do the trimming ourselves, because we're gonna need the trim path for us anyways. So path equals use derived value, and we trim the path manually. So that would be if the, and that's something in React Native Skia we should maybe fix, right? The trim API, which, because we try to mimic The CanvaKit API, we don't accept any. So if we have 0, 0 or a trim value of 1, we don't accept it. So you have to do these checks ourselves. We have to do these checks ourselves, but I think it's a bit annoying. We'll probably fix it in React Native Skia to allow values which are 0 range, which is a trim range, which is 0, 0 or 0, 1. But here we have to do a check if trim.value equals is greater than 0 or less than 1. If not, we return the full path. We are going to do a copy of the path, trim it from 0 to trim value, and the complement argument is false, which also should be optional. So these I should really fix, and if I forgot to fix it, please remind me on GitHub. So let's have a look. I think here I need to remove this value. So it's definitely, I think, more testing and ergonomy that needs to be added to the trim function. But okay, that looks good. Now we can add the head. So I can, and this is where we need kind of the path. So I can call it head. Can put the color. That's not the final color, but this color. And so the head is a derived value from path. Oh, that looks good. No, that's not good. We take the path value, get last point. And that's the center of our head. So that looks good. So the first thing we can do now is to add the sweep gradient to the ring. So colors are colors, center is a center. Let's have a look. So this looks good, but of course, when we hit more than one revolution, we need to rotate it, to rotate with it. So we're gonna add a matrix to rotate it. Should I call it maybe matrix is too generic of a name, but okay. So we create our Skia matrix. And so if we need to rotate it, and we need to rotate it if we have more than one revolution. So we have the progress. The progress is trim.value times total progress. So yeah, I mean, we have a rotation angle. So that would be, so this is correct. But if progress is less than 1, we return 0. On the first revolution, we don't rotate anything. And so I guess here we can do the rotation. So if angle is greater than 0, and here it's, so again, another source of confusion in the Skia API. And here again, it's because we really wanted to follow the symmetry with CanvaKit. So there is, in many places we use degrees, other places we use radians. It can be confusing. I tried to make it a bit more consistent, but actually it's used in so many places and it's a very tricky actually problem to solve. Like also if we wanted to do it in a backward compatible way, that's the most, I think, we would have to break backward compatibility, which would be really annoying. So that's why we have this inconsistency into the imperative API. But so here will be matrix rotate with the angle in, here it's in radians, so it would be 2 times pi. And of course we need to add the pivot point, which would be at the center. And yeah, in here I guess I can call it M. It seems like it has worked already, I see it. on the side. So now the last step, there are still a couple of steps, but it's getting there. I think you can tell. Slightly getting there. I think what we can do here is to add the circle of the head. So if the head is at more than 100%, of course here the color is correct because we rotate the sweep gradient. But let me, just so we can see the issue, look at values less than. So you see here the color is wrong. There are three ways to solve this problem. I think the first one would be to really understand how the sweep gradient in Skier interpolates the color and use exactly the same interpolation to find exactly the color. The second solution would be to use your own sweep gradient, where you use your own interpolation and so you know exactly the colors. The one I'm going to do, at first it felt like it was a bit a silly and lazy way to do it, but it turned out also to do the shadows is going to be very convenient, is that I'm going to pick at the color directly from the sweep gradient using a shader and use this color. So first it felt very silly and lazy, but actually if we do the shadow with a shader, it's like kind of convenient because you put it all into one into a shader. But so let's do that. I'm gonna use the sweep gradient. I mean, okay, of course here it works, but if we, let me put one to more than 100, you see now it doesn't work anymore. And so what I'm gonna do is to wrap it into a shader and pick at the color where the head is. And so I think I have a base, I have a base shader here. I'm just returning the value of the children, so it's not going to change anything. And it doesn't. And I'm going to pass the position of the head, the center of the head in as a uniform. So we have uniforms. So use derived value. And I think, yeah, let's see. So I'm going to return, so let's call it, head, I guess. Let's try that. And here so we have a new, so uniform, head, and we return the position at head. Yeah, well, yes, no, that's correct. So this is good. Of course, here we see it's a circle, so we see it almost pointing. Wait. No, that's a wrong. I think what I should do is, if this is still correct, I think it's just that if we are at progress is greater than 1, we return the color. So I'm gonna add a uniform progress and uniform color. So progress is trim dot value times total progress. And the color, so here again, one of the quirk of, so we have the color which is color 1, and we can, so it's a string, but we can make it as a float array 32 using Skier color. But there is a bug in the reanimated free integration. So here we need to copy the array. So this should work now. Yeah, now it works nicely. Again here, so this is a bit of a hot topic for us. There's a couple of small issues with the reanimated free integration, and we're gonna document them in the very, very short term. I think by the time this video is published, some of these quirks should be nicely documented, and hopefully from there we're gonna fix all of them. So now we can add the shadow. And so one way we can add the shadow is to do shadow and clip. But I think we're gonna use a shader. Let's see. So I just add the shadow, blur, let's say 15, right? That looks good. And of course we need to clip the half of circle. Can we do this quickly? So let's add first a non-rotated rectangle. And that would be Skia. Yeah. So which values do we have here? So that would be head.value x. Oh, I mean, can take it here. Just so c.x minus, let's say, stroke width. c.y, that's correct. And then there will be stroke width, I guess, times 2, or here. I mean, here this value is random, right? I think. Let's see what. Okay. Let's draw it. That actually looks good. We just need to rotate it. So let's rotate it. We create a matrix. We're gonna rotate from the center. Wait, which would be C, yeah, c.x, c.y, so that's our pivot point. And the rotation is gonna be the same than the one we used for the sweep gradient, except but we want to do it at the beginning, not only after the first revolution. So this would be, I think, the angle. Let's have a look. Ooh. So progress is trim.end, yeah, trim.value times total progress. No, because we forgot to apply the transform. Let's have a look. Great. So that's fun. So now we can use this as a clip. Here. And I can remove this one. So one thing we can see already is that we need to make the circle a bit larger. Where are we? Where? I'm lost. Where is the circle? Head clip. Okay. So we can do minus stroke width, and here we could do stroke width divided by 2, multiplied by 2. I think this should be good. Yeah, perfect. So really nice. And so now one thing we can do for fun is to use a shader instead. So Yeah, I'm gonna remove these, like the clip. Let's make an experiment. And so this is okay, but here instead of a circle, oops, I'm gonna use a fill. And head doesn't exist. Yeah, okay. Here head is path.value get last point. Okay. So let's see. I think I need to pass some values. So the head is correct. I can pass a radius, which would be stroke width divided by 2. And so I have radius here. And I could say if, so we can calculate the distance. So the distance from the head. So if d is greater than radius, should I return black? Yeah, that works. But I think what I want to do, so if we want, that's good too. But this is great. This is great. So I return transparent. And let me remove. Interesting. I mean, I could use the shadows directly, but I'm going to remove it. Okay. No, I couldn't use it. Sorry, I was confused. So here we want to draw the shadow, right? So we want to go from black to transparent. So black if the distance is at 0. It doesn't even have to be. Yeah, I think it's easier this way. Yeah, so if the distance is 0, we go to black, and if we're at 40, we're fully transparent. Oh, this is nice, right? And I think what we need to do now is to clip. So how do we clip? If the y value is less than head.y, let's say return transparent. That looks good. That looks good. We just need to rotate it now. And so I have a rotate function here. So I can do rotated. So I rotate xy on the progress times 2 pi, I guess. That's correct. And head would be the, I think that's correct. Here I can, just for good measure, write it like this. And if the rotated, that's correct also, but we just, of course, let me remove the rotation. Minus pi minus. What? So here we make it greater. Perfect. Let's have a look. This looks really nice, a bit simpler than using the clipping mask. What's interesting here is that actually now we did the most complicated part using the shader. So I think now we can really see how we could do this only using a shader and nothing else. And I believe that this is how it's implemented on the real iOS app. And that's how we should have done it, I think, in 2020. Of course, back then I had no idea on how to build these things. If you would like me to start from this and build a fully, like a full shader solution, let me know in the comments below, I will do it. But I think here, really the point of the tutorial is to show how to use these Skia primitives nicely, the path animation, the angular gradients, rotating the angular gradients and so on. So I think the value is really in like exploring these APIs. We saw also some quite some quirks. So yeah, let me know what you guys think. I am looking forward to talk to you soon, and until next time, happy hacking.